Good morning everyone. Today we will see the Uniaxial loaded column design problem. Myself Dr. J. Savarun, Professor Head, Department of Civil Engineering, Rogini College of Engineering and Technology, Kanyakumari. Okay, let us see the problem. The problem using SP16 design a longitudinal reinforcement of the rectangular column of size 300 by 600 mm. Subjected to a factor load of 1400 kN, factor moment of 280 kN with respect to major axis. So the material used in this problem is M20 grade concrete as well as Fe415 steel. So the given, based on the given data, just we have to take the values of B and D. FCK 20 Newton per mm square, Fy 450 Newton per mm square. Then PU, that is a factor load, ultimate load is given directly 1400 kilonewton. MUX, that is factor moment with respect to major axis is 280 kilonewton meter. So we have to use SP16 chart that reinforcement is distributed on 4 sides. That is a equal reinforcement on 4 sides may be used. So chart number 43 to 46 we can use for design of this column, this rectangular column, that SP16 of chart 33 to 46. Let us see the chart and find out the non-dimensional parameter. From that we have to find out the percentage of steel reinforcement. So first of all we have to assume that cover is 60 mm. So d dash by d, first we have to find out the value. Before that we find out the non-dimensional parameter of PU by FCK BD as well as MU by FCK into BD square. Okay. So PU given in the problem is 1400 into 10 power 3 divided by FCK is, we know the value of 20, then B into D, 300 by 600, we will get a value of 0.389. Like we have to find out the MU by FCK BD square. So MU is given in problem is 280 kilonewton meter. So 280 into 10 power 6 divided by 20 into 300 into 600 square. So that will be is equal to 0.13. So based on the non-dimensional parameter like PU by FCK BD as well as ME by FCK BD square, we have to find out that we have to use that SP16 chart. The distribution of reinforcement is all 4 sides equally distributed. So find the value of P by FCK. From that we find the percentage of reinforcement. Then we have to find out the area of steel reinforcement. By referring the chart number 44, that of SP16, D dash by D 0.1. Already we D dash is 60, D already know 600, so the value is 0.1. So that percentage we have to find out. So from the non-dimensional parameter we have to take the P by FCK value. Okay, P by FCK is equal to 0.11. This value is get it from the chart number 44 of SP16. So we will get a value of 0.11. So the percentage is required is 0.11 into that FCK 20. So that value is 2.2. 2.2 is the percentage of steel reinforcement. From that we have to find out the area of steel required. Okay, so 2.2 is the percentage of steel is required. So 2.2 divided by 100 into 300 into 600. Okay, so the percentage we have to convert into numerical value, that is 2.2 divided by 100 into 300 by 600. The value is equal to 3960 mm square. This is a total area of steel required for the given section. That is AST required is equal to 3960. Okay, so this is a reinforcement detail. So from that we have to give a main reinforcement. Okay, we have to provide 4 numbers of 28 mm in the corner direction. That is 4 number 1, 2, 3, 4 numbers of 28 mm diameter bars in corners. And also we have to provide 4 numbers of 22 mm diameter inner side. Okay, this is a so total AST required. Based on we have to give a reinforcement in corner as well as intermediate. So that in inner rows we have to give a spacing like 200 mm center to center. So this is a reinforcement arrangements of the rectangular section. They are having a size of 600 by 300. This is a reinforcement arrangement. So this is all about that design problem of rectangular column section. Thank you so much.